So when you operate these devices in negative resistance region, this region is highly unstable, so they start oscillating. Okay, so tunnel diode is a very simple example for a negative resistance oscillator, and you can see this is the equivalent circuit of tunnel diode. You have R and RL series parallel to C, and this negative resistance will come if you are operating the negative resistance region. Otherwise, this minus Rn will not come in the tunnel diode. Minus Rn will come only if you are operating the tunnel diode in the negative resistance region. So the equivalent circuit R equivalent will represent Rn parallel to minus Rn. So only two resistance are there. If you consider the DC resistance across the circuit, R will be parallel to minus Rn. So I am writing R equivalent value as minus Rn into R by R minus Rn. So if R is greater than Rn, R equivalent is negative and oscillations will build up. So ensure that R equivalent is always negative. Only if R equivalent is negative, oscillations will start building up, and they will grow up until it becomes sustained, and then it will cover the entire negative resistance region of your oscillator. So when the operating point enters the positive resistance, the amplitude becomes limited. So to obtain maximum output, the Q point is exactly located in the middle of the negative resistance region. We have seen in the graph, this is the negative resistance region, so the Q point has to be present exactly in this midpoint. So if you choose this way, then it will work as a perfect oscillator. So if you choose the Q point somewhere here or here in the positive resistance region, then it will work as an amplifier and it will not work as an oscillator. And the frequency of oscillation is given by f naught equal to 1 by 2 pi root LC, where LC is the components what you connect external to your circuit. The tunnel diode has negative resistance characteristics, and the negative resistance region happens at very low voltages, and it can produce oscillations up to 100 gigahertz. So in the very high microwave frequencies or very high frequency region, these tunnel diodes will be of very much importance because they generate oscillations at 100 gigahertz, which are not conventionally possible to generate oscillations by RC phase shift oscillator and LC phase shift oscillators. So those oscillators will not work beyond 100 megahertz, but the tunnel diode works at 100 gigahertz, generating sustained amount of oscillation. So this tunnel diode finds a special application in all your radio frequency and high frequency applications. High frequency applications where the oscillations are required. So this completes your unit 4.